our next talk is about yabits, a quite different way of approaching UEFI. So please give a big round of applause for Akira Moroo.
Thank you. Thank you. In this talk, I'll talk about yabits, yet another UEFI corporate payload. And here's an abstract of this talk. UEFI is a de facto standard BIOS specification, and there's two types of UEFI implementation: closed firmware and Tiano cores, and the both have each problems. And so I propose yabits, a new UEFI implementation, and it's fast and lightweight. So this is my bio. I'm Akira Moroo, a graduate student at Tokyo University of Science, and I major in electrical engineering, and I'm researching in the field of software engineering. And I'm interested in firmware, core boot, UEFI, and the boot process of operating systems. And I have plotted mRuby. mRuby is a small subset of Ruby language, and I plotted it to UEFI shell in 2015, and I started yabits project in 2017. So maybe people in this room know about this, and but let's recap about BIOS. BIOS, there is two types of BIOSes for x86-based PCs, legacy BIOS and UEFI. Legacy BIOS is the original is a BIOS of IBM PC in 1981, which is a very old PC, and it runs in 16 real mode for backward compatibility, and it does not standardize for. So there's many incompatible extensions for the legacy BIOS. So it is not suitable for modern x64-based machines. So UEFI is proposed in 2005. So UEFI is a unified extensively firmware interface, and it is based on EFI developed for IA64 by Intel. And it is standardized by UEFI forum, and you can find the specification online. And UEFI supports many architecture, like from IS64, IS32, x64, ARM64, RISC-V, and MIPS. Compared with legacy BIOS, UEFI provides a lot of protocols. Almost all x86-based PC are shipped with UEFI firmware. And next, I talk about the current UEFI implementation. And as I said in previous slide, there's two types of UEFI implementation, and each is the Tiano core and the other closed firmware. And Tianqua is an open source UEFI reference implementation developed by Intel and its communities. And CrossFarm is developed by BIOS vendors or mainboard vendors. And CrossFarm is based on Tianqua and adding some special features. Like very graphical or gaming support. And this slide is from Black Hat USA last year. And this figure shows the ecosystem of UEFI. And the center is here Tianqua, and which is an open source project, and vendors use the open source repository and provide to other or as OEM BIOS, and users use the BIOS, and the problems in current UEFI is the bugs remain fixed if vendors do not provide updates. So, and the features such as graphical or something features shipped without enough verification, and users cannot fix the bug unless they reverse engineering the firmware. And the most of cross firmware uses Tianqua code base, so they have same vulnerability even shipped from different vendors. This is an example of Thunderstrike 2, which is discovered by Trammell Hudson. So I think there is a problem when we using cross firmwares. So here's one simple solution. Use Quabut. Yes. Quabut is an open source BIOS platform, and it supports various mainboards, and the Quabut has a machine-dependent part and payload. And payload is a machine-independent part, and which we can put the payload to a freestanding ELF executables. And here's an example of what kind of Quabut payload here is. CBIOS, Tianqua, Philo, Grab2, Linux kernel, Plan 9, or so on. So we can use Tianqua as a Quabut payload in a Quabut payload. So Tianqua on Quabut is the answer to the previous problems. But I don't think so, because Tianqua is too big from the view of just booting operating system. There's unused device drivers and protocols, and because of this, its footprint is very large and takes long boot time. So I think there's 4 requirements for the new UEFI implementation. 1, open source. 2, another code base from Tianqua. 3, small footprint. And 4, booting fast than other implementation. So I propose yabits, yet another UEFI implementation. And the design of yabits is very simple. I just focus on just booting operating system, and so it provides just minimal features, only boot services and runtime services. Yabit is just a one core boot payload, and it has same interface as same as UEFI specification. Yes, it's of course because the main purpose is booting UEFI. Sorry. Booting operating system from normal UEFI firmware. So, and Yabit has no CSM mode, which provides compatibility from compatibility from legacy BIOS, and so it's just class 3 UEFI, pure UEFI for 2020, and the Yabit provides following 4 features: boot services, runtime services, EFI system table supports, and GUID partition table disk layer support, and just these 4 features. So this is very everyone have seen such boot sequence of UEFI. This is somehow simplified model, but I think in Dixie phase, there's many drivers loaded. So I think if the drivers are just a few, only 2 or 3 drivers loaded, we can shorten the boot time of the firmware. So and the implementation is of Yabit is from Minoka OS, which is a Unix-like operating system written from scratch, and it has small footprints and suitable for embedding system. The description says, and what is most important thing is Minoka OS has includes bootloader and UEFI for booting Minoka OS itself. So, and the UEFI or Minoka OS in x86 is something like a piano core duet package like support. So it boots from legacy BIOS and launching the UEFI itself. So I ported this UEFI of Minoka OS to quadroot payload and make it run on the real machine. And Yabits is currently support two architecture, IS32 and x64. And Yabits is deeply dependent on live payload, which is a library for quadroot payload. And And I also ported live payload to x64 to use the code base. And so I added some translation from protected mode to long mode. And yabits has only two device drivers, just IDE and HCI. So, and yabits is an open source project, so here this link, the link is, the source code is available on this link. So, and the license is ZPL v3. So yes, you can try it. You can try it. So let's see. I'll show you the demo. This is execution on QEMU. It's boots. Yes, it's too fast to show you, but thank you. But at this phase, it's already boot up OpenBSD bootloader, and its boot, yes, OpenBSD boot is very long, so skip. Yes, we can use shell as normal and using some use it as a web server. So yes, you can use it as a normal operating systems. So next, I show you the comparison of the boot time of yabits and default BIOS of Lenovo ThinkPad X230. Okay, this is the results, but let's start. Okay, so I evaluated the boot time on the machine, on real machine. So the boot time of yabits is 2 times faster than that of default of ThinkPad X230. And I also tested on QM with OVMF, and the boot time of yabit is 9 times faster than that of OVMF. And what about footprint? I compared the binary for QM, and here's the Tiano core and OVMF and yabits. And Tiano core is Tiano core itself and core boot. And this shows the footprint of yabits is 10 times smaller than that of Tiano core. And so here's many to-do lists as a future work. Yabits is currently supports only x86 based GPU, so I want to add ARM architecture support. And yabits currently does not have a setting menu, so I'll add a setting menu to yabits. And people concern about the security will need secure boot. So secure boot support will be is desired. And as showed before, yabits provides just a very few protocol, like simple text input or output protocol. So it does not provide graphic output protocol. So I will add a graphic GOP support. And the biggest milestone is supporting Windows boot, but it will be it may be a very hard task. So, and yes, yabits has just one contributor, me, and I'm looking for someone contribute to. So please give us a pull request and please contribute. So as a conclusion, UEFI replaced legacy BIOS, and there's two types of UEFI implementation, Tiano Core and other closed firmware. And Tiano Core is too large in the view of just booting operating system, so I propose yabits, which is a fast and lightweight yet another UEFI implementation. And it's designed for embedding system and bare metal clouds. The link below is the official site of yabits I provided. So let's take a look. Please look at this page. So that and I'm this yabit is just my private project, so I'm looking for a sponsor something so that I can continuously working on this project. Thank you for listening.
Thank you for doing this talk. Okay, we have a lot of time for questions. Oh, there are questions.
Hey, thanks. Thanks for the nice presentation. This is Shubrata from Intel. Can you hear me?
Okay.
Yeah. So my question is that you told that you were using lib payload, right, for all the drivers. You were not using UEFI any services and all for the driver and all, right? For example, your SATA or your eMMC, different booting media, right? So you are using lib payload?
Sorry.
Can you go to your some slide earlier?
Sorry. Back to sorry.
Yeah, maybe just you start with that. I'll just stop you. Lib payload or somewhere you mentioned.
Sorry. This sorry. Then which?
Yeah. Here,
this
right.
thing, okay.
Yeah. So can you just see the second line that you mentioned, that deeply dependent on the lib payload,
Yeah.
right? So so today the depth charge is a payload for Chrome OS, right?
Yeah.
So depth charge is heavily dependent on the lib payload.
Yeah.
Right? So from Intel side, the Intel run lots of their validation with UEFI shell, right? Because we use Windows world, we use UEFI, and we have lots of application like for our validation side that we run from the UEFI shell. But when it comes to the Chrome OS, we cannot run the same service with the UEFI shell because the UEFI uses its own native stack. And we want to run something based on the lib payload service and all, right? So there I could see a good opportunity to use your payload. And I'm not sure that do you have any shell kind of environment where you stop your system and we can run the native shell applications and all?
Sorry, sorry, sorry. The question is device driver is the sorry. Sorry, the question is...
Yeah, so never mind. So I just mean to ask you that do you have any console where you stop your system and you can run some application before booting to OS?
Yes, it provides con out, con ins, such as UEFI specification says. So I yes, I provided con in, con out, or STD error to from live payload printer something. So yes, I provide.
Yeah, never mind. I'll just send you an email, so that will be help you to summarize. I will send you an email with my proposal.
Sorry.
Hey, no problem. Yeah, welcome. Most welcome.
Okay, another question.
Thank you. What sort of licensing do you have?
License. Okay, license.
Yes.
Minoka OS is ZPL version 3, so the yabits also licensed under the term of ZPL version 3, and some code imported from other projects is BSD license. So yes, but mainly ZPL v3.
Thank you.
So I'm interested in the comparisons you're making on time with the payload, because I mean the speed that you're getting is very good, but you're comparing the original BIOS, which has a number of capabilities you have imported and a number of drivers that you don't have, like GOP, and the UEFI payload at a fixed configuration. So to get the scale down you were looking for in yabits, did you consider taking the payload and rebuilding it with some of the modules you didn't need removed? In other words, taking the modularity already in Tiana and scaling a solution down rather than, are you using a scale down solution to compare to the speed you're getting, so that you're essentially comparing the same type of payload in Tiana to the exact capabilities you have in yabits?
Yes. When I generate core boot ROM, I fix the size of core boot, fix the core boot ROM size to fit as the size of the payload size. So it's yes, I tried to equal condition, try to provide provide a condition to Tiano core or OVMF or yabits. So it's yes, Tiano core. On Tiano core, it's Tiano core Tiano core boot payload and core boot itself, and yabits on yabits is on yabits it's also yabits and core boot itself. So it can be I think it can compare with comparable. Yeah.
So the Tiano core plus core boot that you have has GOP or no GOP?
Oh, sorry.
The Tiano core example you have, does it have a GOP driver or a graphics driver of some kind?
Okay. Sorry.
The Tiano core, does the Tiano core example you have initialize graphics? Does it turn on graphics?
Okay. Sorry.
Yeah, we'll discuss offline. We can talk outside.
Sorry.
I'd like to ask you a question about the Tiano core, right? What? No, but this is what you're asking. Does this yabit is actually stripped Tiano core, right? Yeah, we can talk offline. Thank you.
Okay. Right.
Is it possible to use yabits to build a DXE, that would then be usable in Tiano core?
Yabits includes entire phase of UEFI phases, so maybe it cannot load yabits in Tiano cores. So,
But are there DXEs that yabits builds as part of yabits, or is it one single binary?
yes.
It's a single binary?
Yes, it's a single
Okay.
binary.
Thanks. Very nice work.
Any more questions? Okay, thank you. Give a round of applause for Akira Moroo.